In this report, I am going to discuss about the inventory of phytoplankton during the assessment in Sitio Linao, Barangay Tinoto in Maasim, Sarangani Province. The researchers of this assessment were Luigi Manyoza, Arnold Solamo, Precious Grace Tukip, and yours truly, Manlangit Robert. The biodiversity assessment site was carried out in 2 stations in Sitio Linao, as you can see in the picture on the right side of the presentation. On March 31 to April 3, 2022, the coastal and marine ecosystems of the assessment stations and its constituent species were evaluated in this assessment. Phytoplankton samples were collected vertically, towing a canonical planktonet with a length of 0.65 meters, a mouth diameter of 0.21 meters, and a mesh size of 25 micrometers, from a depth of 10 to 15 meters and up until the surface. The collected samples were contained in a bottle and preserved with 1 drop of Lugo solution and formaldehyde. The quantitative analysis samples were maintained with 3 ml of Lugo solution. Generally, a clear yellowing of the sample indicates that the proper amount of Lugo solution has been added sufficiently. 1 liter samples collected during the sampling were preserved in the cooler for counting and phytoplankton identifications. The standard methods of sample preparation and microscopy were utilized from the methodologies of Borja 2012. So as you can see here, we have our materials during the field sampling of phytoplankton assessment. First one is the styrofoam or the ice box, where the 1 liter samples were stored for preservation, and the chemicals were Lugo solution for preservation and dyeing, and 30% formaldehyde for preservation. Phytoplankton was identified to the genus level by observing the cell's morphological characteristics under the light microscope, with the aid of several identification guides from references such as Identifying Marine Phytoplankton by Thomas 1997, Marine Phytoplankton Atlas of Kuwait's Waters by Al-Kandari et al. 2009. An online taxonomic database, the World Register of Marine Species, or most commonly known as WORMS, and the algae base was also used to correct the scientific names from older publications and match them with the most current accepted scientific names. The Shannon-Wiener index equation was also used to measure the biodiversity of phytoplankton in Sitio Linao. So the equation goes as the negative summation of pi times ln pi. So the H indicates the index of Shannon-Wieners. Pi is the proportion of total sample represented by species, and this can be solved by dividing the number of individuals of species to the total number of samples or species. The Fernando 1998 scale was used as the diversity criteria for our Shannon index value. According to Fernando, a Shannon index value greater than 3.5 indicates a very high diversity, and a Shannon index value less than 1.9 has a very low diversity. For the results, there were recorded 23 phytoplankton genera identified in the 2 sampling stations of Sitio Linao, Maasim, Sarangani Province. These species are categorized among 3 major taxonomic groups based on their specific classifications, namely cyanobacteria, diatom, and dinoflagellates. So as you can see, here are the actual photographs of the identified genus in the 1 liter samples that we've collected in Sitio Linao. So we have Helicotheca, Ginardia, Cossinidiscus, Hemialulus, Stephanopixis, Chaetocerus, Protoperidinium, Serratium, Pyrophacus, Firmidium, Oscillatoria, and Thalassoneमा. Sitio Linao has a total of 23 genera of phytoplankton comprised mainly of 18 genera in Station 1 and Station 2 respectively. There were 16,109 individuals recorded in Station 1 and 47,406 individuals in Station 2, which would equate to an overall abundance of 63,513 individuals. The overall result was dominated by cyanobacteria, oscillatoria, and Firmidium. As reflected in the study, the overall mean density of Sitio Linao was 63,517.62 cells per liter and abundance value of 33,000 cells per ml, and has three major classes: Bacillariophyceae, Cyanophyceae, and Dinophyceae. The Cyanophyceae was the most abundant and has the highest cell density in the sampling site, represented by Oscillatoria and Formidium. The presence of Oscillatoria indicates higher nutrient status, and this nutrient increase caused by agricultural and organic waste discharge together with other anthropogenic activities along the shore has most likely influenced phytoplankton composition in the study area. The parameters of the selected diversity indices, such as species diversity, provide information about the structure and organization of plankton communities. The values of the indices are used to determine the condition of the water system. In the case of Sitio Linao, Maasim, the computed diversity value in this present study, which is 1.301, is very low based on the Shannon-Wiener diversity scale developed by Fernando 1998. According to Margalef, phytoplankton diversity is typically between 1 and 2.5 in coastal waters, 3.5 to 4.5 in oceanic regions, and 5 in open tropical oceanic environments where phytoplankton have low productivity but a wide variety of species. Based on the data presented, the researchers studied the distribution, diversity, and abundance of phytoplankton in Sitio Linao's coastal waters. The following conclusions were drawn. The study area is composed of three primary phytoplankton groups that consisted of blue-green algae with 2 genera, diatom with 18 genera, and dinoflagellates with 3 genera. Cyanobacteria dominated both study stations, with Oscillatoria being its abundant genera, followed by Formidium. Diatoms has the highest number of genera recorded during the sampling period with 18 genera. Dinoflagellates were the least abundant of these organisms with 3 genera, namely Ceratium, Protoperdinium, and Pyrophacus. Based on the data gathered, the area has a mean density of 63,517.62 cells per liter. The status or condition of the phytoplankton community of the assessed area is categorized as a very low diversity following the criteria from Fernando Scales' 1998 category for Shannon's Index. Assuming phytoplankton spread is not limited by dispersion, the local environmental variables influence the phytoplankton community structure in Sitio Linao. Thus, the researcher recommends phytoplankton diversity indices can be employed to evaluate pelagic ecosystem health. Monitoring phytoplankton can also provide feedback on the influence of land use and fertilizer inputs on water quality. Also, future phytoplankton studies should attribute water quality parameters to natural and anthropogenic causes to gain a deeper understanding of the phytoplankton composition and abundance at Sitio Linao. Also, phytoplankton monitoring should be conducted and institutionalized to determine the impact of nutrient loading on coastal waterways, particularly in Sitio Linao, Sarangani Province. That is all for this report. Thank you.